In this lesson, you will learn to determine whether a sequence is arithmetic, geometric, or neither, and to supply missing terms of a sequence. Now, when we say sequence, we need to know what does a sequence mean. And I think many people have a general idea of what a sequence means, but a technical definition is a list of numbers in a particular order. So for example, we see here 2, 5, 8, 11, 14, etc. And the pattern is that you're adding 3 every time. 2 plus 3 is 5, 5 plus 3 is 8, and etc. Another definition to know is the word term. A term is each part of the sequence, or each number in the sequence. So for example, if we are dealing with term 1 would be 2, term 2 is 5, term 3 is 8, and etc. Now, instead of writing out the word term every time, a short way to signify a term is by using the letter T. So T1 means term 1, T2 means term 2, and T3 means term 3. Some other definitions to know is the different types of sequences. So we have sequences that can be determined based on the number of numbers in the sequence and also based off the pattern. So here we have finite sequence. A finite sequence is a sequence with a limited number of terms. So for example, here we see 8, 4, 2, 1, 1/2, 1/4. Notice there's only 6 terms. That would be finite. And that's as opposed to an infinite sequence, which keeps going on forever and ever and ever. So for example, 8, 4, 2, 1/2, 1, or 1, 1/2, 1/4, and it keeps going, and we can tell it keeps going because of the ellipses right here at the end. These 3 dots means that it's going to keep going forever and ever. Now, we can also define our sequences based off the pattern. So we have what we call arithmetic sequence and a geometric sequence. By the way, a little side note, it's pronounced arithmetic because it is an adjective describing the sequence, whereas the word arithmetic is a noun, so it's pronounced differently. With that aside, how do we know the difference between these two types of sequences? Well, an arithmetic sequence is a sequence in which each term is found by adding or subtracting to get to the next term. So for example, 10, 13, 16, 19, etc. Notice each time we are adding 3. Right? 10 plus 3 is 13, 13 plus 3 is 16, 16 plus 3 is 19. Because we are adding something to get to the next term, we would consider this an arithmetic sequence. A geometric sequence is when you multiply or divide to get to the next term. So here we see 4, 8, 16, 32, and 64. And notice each time I'm multiplying by 2. 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 gives me 64. So because I'm multiplying by the same number each time, this would be considered a geometric sequence. A little side note as well, if you look at the first example, and you had plus 3, plus 3, plus 3, and let's say the next number was 21, then this would not be arithmetic sequence because the pattern is broken. We're not adding 3 every time. Now we have a plus 2, so therefore this would not be arithmetic. Same thing for geometric. If you were multiplying by 2, and then the next one you multiplied by 3, then that would not be geometric because the pattern needs to be the same. Now looking at arithmetic sequences, we have what's called the common difference, which is what we add to get to the next term. We use the letter D to represent it, and an example of this would be looking at the same numbers we had before, 10, 13, 16, 19, and etc. Because I'm adding 3 each time, my common difference would be 3. Now if you were going the other way, where you had 19, then 16, then 13, and 10, etc., notice I am subtracting 3 each time, or I can think of this as adding a negative 3. Because of that, my common difference would be a negative 3. So take note of the difference between a positive and a negative common difference, because many people will forget or mistake on the positive and the negative, which will make a difference as we get into later sections of this chapter. Now we have a question where it says to find the common difference and the next two terms of the sequence. So here we see 50, 45, 40, 35, 30, etc. And the pattern is that we are subtracting 5 every time. 50 minus 5, 45 minus 5, etc. So because of that, your common difference would be that minus 5 or negative 5. And the next two terms are found by continuing that pattern. So I subtract 5 again from 30 to get 25, and then subtract 5 from 25 to get 20. Now let's discuss geometric sequences. Geometric sequences, we have what is called the common ratio, which is what is multiplied to get to the next term. So just like the common difference is to an arithmetic sequence, the common ratio is to the geometric sequence. So the common ratio is represented by the letter R. And here's an example where we have 3, 6, 12, 24, etc. Now notice the pattern is we're multiplying by 2. So because we're multiplying by 2, 2 is going to be the common ratio. If it's going the other way, say we had 24, 12, 6, 3, etc., we can see the pattern is dividing by 2, but the ratio can't be 2 again because they're two different sequences. The first one is multiplying by 2, the second one is dividing by 2. So go back to the definition of common ratio. The definition is what is multiplied to get to the next term. So what are we multiplying by to get from 24 to 12? Well, yes, we're dividing by 2, but dividing by 2 is the same thing as multiplying by 1 over 2. So what I'm doing is I'm multiplying by 1 over 2, so my common ratio would be 1 over 2, or 1/2. There are times when the ratio might not be as obvious as it is here. So a way to find the common ratio, if you can't tell right away, is we just take a number and divide it by the number before it. So if I take a 6 divided by 3, notice I'm going to get a 2. Or I could take the 12 divided by 6. Either way, I get a 2. Same thing down here, 12 divided by 24 would give me 1/2. 6 divided by 12 gives me 1/2, or 3 divided by 6 would also give me 1/2. Here's an example where you're told to find the common ratio in the next two terms of the sequence, given 2, 6, 18, 54, and etc. Well, the pattern here is you're multiplying by 3 every time, and so the common ratio would be 3. And then the next two terms you find by continuing that pattern. So 54 times 3 would give me 162, and 162 times 3 would give me 486. Here's another example where we have 80, then negative 40, then positive 20, and then negative 10, and etc. So the common ratio, remember, is what you're multiplying by to get from term to term. Or the other way to think of it is we can take a number, say negative 40, and divide by the number before it. So negative 40 divided by 80 would give me a negative 1 over 2, which is my common ratio. And then the next two terms of the sequence is found by continuing the pattern. So I divide 10 by 2 again to get 5, and then it's going to be positive because the sign is changing from positive to negative, positive to negative. So next one would be a positive 5, the following would be a negative, and then take 5 divided by 2 to get negative 5/2. Now this next example, you are given a formula, and the question is, what if you wanted to know the 50th term? So here we are given a formula, whereas later we will have to find the formula ourselves and then figure out the solution. But for now, we're trying to find the 50th term. Well, the 50, what I do is I just plug that in for n. Because if I plug that in for n, right here, I'd have t and then 50. And remember, this notation means term 50, or the 50th term. So T50 would equal and then plug a 50 in for n right here as well. So I have 5 plus 4 times 50. 4 times 50 is 200, and then 200 plus 5 would be 205. So that is my solution. So all I do is plug in the number in for n and then solve. And then here is an example where it's not arithmetic or a geometric sequence, but there is a pattern, and we can try to find the pattern to figure out the next couple numbers. So take a moment and see if you can find the pattern yourself. Once you have thought for yourself to determine if you can find the pattern, now I'll walk you through to see if you got it correct. So notice, to get from 2 to 6, we have to add 4. Okay, and then to get from 6 to 12, we can add 6. To get from 12 to 20, we're adding 8. And then to get from 20 to 30, we are adding 10. So notice there's a pattern within the numbers that we're adding to get to the next term. We add a 4, then a 6, then an 8, then a 10. Keeping the pattern going, we'd have to add 12, and then add 14, etc. So this pattern in the sequence is kind of 2 layers deep. It's not here in the first layer of 2, 6, 12, 20, and 30, but the pattern is in the second layer of numbers that we're adding to get to the next term. So keeping this pattern going, we'd have to add 12 to 30 to get to 42, and we want to keep going further, we can add 14, and etc. But we just want to know the next term, which is going to be 42, and that is my solution. And that concludes our lesson for today. We will see you next time.